All right, let's talk about one of the toughest problems in engineering, the scale-up challenge.
So, picture this. You've made a breakthrough medicine in a tiny beaker, and it works perfectly.
But now, you've got to make millions of doses. We're talking factory-scale production here.
So, how do you do that without messing up the recipe? That's the scale-up problem. Because it's not just about getting a bigger bowl, the actual physics of it all starts to change. Some things, like temperature, are easy to keep the same. We call those scale-independent.
But other things, like mixing, they behave completely differently at large volumes. That's the real problem.
And here's a big reason why. As you get bigger, your volume grows way faster than your surface area.
Think about it. A small beaker cools off fast. A huge tank can overheat and ruin everything. So how do engineers solve this? Well, they've got a couple of powerful principles to guide them.
First up is dimensional analysis. It helps them figure out which physical laws are really in charge.
And second, quality by design, which makes sure they're focused on what truly matters, the final product.
But even with these tools, engineers have to make a really tough choice. An impossible choice, really.
Check out this table. You just can't keep everything the same. Tweak one thing and others go way off.
So, the big takeaway here? You will never perfectly copy the conditions of that small lab beaker.
And that right there changes everything. The goal isn't an identical environment, it's an identical result.
Exactly. The real goal is to find a new set of rules for the big tank that still gives you that perfect product.
So using that quality by design idea, they map out every single little thing that could possibly affect the outcome.
This whole process gives them a clear, step-by-step way to guarantee quality no matter the scale.
So instead of one single perfect recipe, they create a design space, a safe window for success.
It just goes to show you, scale up turns a simple recipe into a super complex science of trade-offs.
So, what else works perfectly small, but just breaks when you try to make it big?